All right, welcome. Math 121 exam question. This is question number 3. You have the past question with you. It may not necessarily be still number 3 in yours. You also need the number 5, 6, or 11. But you still find the same question. So the question says evaluate integral with the boundary from 0 to 1 of x e raised to power x dx. So we are going to do this quickly. Now, the method of integration we're going to use to do this is called integration by parts. Integration by parts. And then in integration by parts, there is an expression that has been developed. I won't begin to solve or explain that. The expression says we have integral of u dv, that it will be equals to uv minus integral of v du. So it is a standard expression to use and do integration by parts. So now let's apply this. So with respect to this, now say let my u be equals to x. Let u be equals to x. And what is left? And then I'll say let my dv will be equals to what? E raised to the power of x dx. The dv equals e raised to the power of x dx. So from here now, my du dx will be equals to 1, which makes my du to be equals to what? Dx. Now dv equals to that. That means if you do integral of what? Dv, you will take integral of both sides for this one, or e raised to the power of x dx. You find out that if we integrate with respect to dv, you find v equals to what? If we integrate e raised to the power of x, will still give you e raised to the power of x. So I've gotten my v, I have my u, I have my dv, and the rest. So what is left now is for me to properly input them into this formula and see what it will give me. So from here now, that means this integral from 0 to 1 of x e raised of x dx can is the same thing. Remember, this is u dv. The same thing uv. Our u is x. Our v is e raised to the power of x. E raised to the power of x minus integral minus integral of v. Our v is e raised to the power of x. E raised to the power of x du. And our du equals to what? Dx. Dx. So if you process this, this will be x e raised to the power of x minus integral of e raised to the power of x is still e raised to the power of x. So which equals to, you factor out e raised to the power of x, that will be e raised to the power of x into x minus 1. All this, and still you have to introduce your boundary from 0 to 1. So we've successfully integrated this to give us this, but we have not applied the boundaries. We have to apply these boundaries, to see what it will finally give us. So let's take another page to do that. So that will now be integral from 0 to 1 of x e raised to the power of x dx, which is now equals to e raised to the power of x into x minus 1 from 0 to 1. I believe that's what we got. X minus 1 from 0 to 1. So applying these boundaries now, the first one will be e raised to the power of, you can place anywhere you see x, you put 1. E raised to the power of 1 into 1 minus 1. That's for the boundary of 1. Then minus, you put in big bracket. You now, this same expression, you anywhere you see x, you put 0. Minus e raised to the power of 0 into x, which is now 0 minus 1. Which will be e raised to the power of 1 is e. Anything raised to the power of 1 is that thing. Into 1 minus 1 is 0. Minus e raised to the power of 0, anything raised to the power of 0 is 1. Anything raised to the power of 0 is 1. That's initial law. Okay. Into 0 minus 1, that will be minus 1 here. So if you process that for that, 0 times anything times 0 is 0. So if 0 left is minus 1 into minus 1. Minus 1 times minus 1 will be 1. So therefore, integral from 0 to 1 of x e raised to the power of x dx equals to what? 1. You may not find this one in the option, but this is the correct thing. It can be proven anywhere. This is the correct thing. All right, take care.